Okay, 10-2 arc measures. We are doing all things circle in this chapter. And so we're going to look at some more good things. So let's start off with this one. We're going to draw an angle that's drawn from the center of a circle, and we're going to identify it. It's going to have a specific property. And so this is what's known as a central angle. Okay, and let's say that this angle right here was 60 degrees. And so if it's a central angle, we have an arc out here. Okay, think, like the arch or arc, however you want to say it, the arch in St. Louis. And that is called an arc. And if it's the arc of a central angle, it is also, well, hello there, crazy board. Let's try that again. It is also 60 degrees. And that only works, and I don't know why I keep doing this. I'm just going to move it over here because I know it'll work over here. If the angle is 60, central angle, then the arc is also 60. And it's part of the circular arc is what you would call it. Now, anything that is less than 180 degrees is what's called a minor arc. Okay, so a minor arc is less than 180 degrees. Getting crazy with the colors today. A semicircle is equal to 180 degrees. A little bit more space here. And last but not least, what was I going to do that in? Green. A major arc is greater than 180, but it is less than 360. And exactly 360 would be a circle. So those are the three types of arcs. A minor arc, less than 180 degrees. A semicircle, equal to 180 degrees. And then we have a major arc, which is greater than 180 degrees, but less than 360 degrees. So how do we label them? Typically, a minor arc is going to be labeled with let's get back to black. Let's go with A. Excuse me, sorry about that. Allergies are getting me a little bit. C. And then I actually want to put a D right there. Okay, so a minor arc, we're going to do 2 letters. So let's go from A to B. We didn't quite go halfway around. I don't want to do yellow because that's not going to be, won't be able to see that very well. Let's do red. So the minor arc is 2 letters. Kind of like a line segment that we label it as, but it's arced on the top instead of a segment. If we were to go, let's say from, let's go with green. Let's continue to go here. We know if we go all the way back around, to A, we know that that's greater than 180 degrees. Because actually BD would be my diameter, so I know that's further. So if I'm going to do a major arc, and order is important, I'm going to do B, C, D. Excuse me, not D. I'm sorry, B, C, A, because A was my endpoint. Now, could I also do A, C, B? Yes, that would be okay. Those are the same thing. But I could not do B, A, C, because again, it goes in order. So B, A, C would go counterclockwise. Starting at B, it would go through A and C. It's not the same one. Now, if I recognized that this was a diameter, I could list that as a semicircle, and I could label that a couple of different ways. I could call that BD. I could call that BAD. I could also call that BCD, because those all have starting and end points of B and D, which gives me that semicircle range. So now let's look at a couple of examples and some problems we might have. Let's just start with the basics. If I were to have, let's say I've got a diameter there. Guess we're stuck on green. And if I told you this was 61 degrees, and let's label, we've got A, B, C, and I asked you what if you could find arc BC. Well, if I want to find arc BC, then I need to find angle CDB. I need to find this angle right here. Because BA is a diameter, that makes BCA a semicircle, so that's 180 degrees. So when I did 180 degrees and I subtracted it from, when I take 61 and I subtract it from 180 degrees, then I'm going to get 119. So if angle BCD, or excuse me, if angle CDB is 119 degrees, then arc BC is also 119 degrees. So we're just finding the missing piece. And that's about 8 minutes. That is 10-2, arc measures.